Hi guys, welcome to week number 6 of System Administration course. I hope you are doing great. I hope you are understanding the concepts we have gone through in previous weeks. So today we're going to talk about system monitoring, how to do system monitoring in Linux specifically. I hope you understand the concepts we have gone through in the previous lectures. Like we did quite a lot of bash scripting last time. I hope you understand that. I have not received any email from any student asking any questions, so I expect that it was clear, everything was fine. Now last time uploading lecture I had a lot of issue with Blackboard, so I uploaded the lecture on Blackboard and then it kept on processing. It took a lot of time. It took almost 3 days to process. Then I had to delete that video and upload that on YouTube. So sometimes things like that can happen. So I normally keep on checking the lectures if it has been processed already or not. So what I'm going to do from now on is I'll make sure that the lectures are processed. Only then I'll show them to you. I'll make them visible to the students. So I hope you have no questions. If you have any questions, please drop me an email or visit me in my office hours and we can discuss further. But if you have gone through any programming language up till now, bash scripting shouldn't be a problem for you. It's just a different syntax. It's just that it's quite sensitive to spaces and stuff here and there, so you just have to get used to that if you are planning to work on a long term in this programming language. So we already discussed about memory management, but that was quite brief. Obviously we had already discussed memory management a lot in previous lectures as well, so that's why I didn't cover too much. And we actually covered almost everything that is related to memory management. For more information in memory management, how paging is happening, how virtual memory is working, obviously a lot of information is in operating system course, which is not obviously this part of this course, so I have not covered that. This is one thing. The second thing is about your assignment number 1. I was very happy to see that everybody completed that assignment, and most of you have got very good marks, which is very good to see. Very pleased to see that. So this is how assignments should be solved. You need to understand carefully what is asked in the question and then solve your exercise accordingly. A few students missed few things here and there. I mean, that's why I didn't deduct too much marks, because it was the first assignment, although those were core areas which you had to cover in your assignment. For example, a few students missed Android drivers, and that was one of the requirement of that scenario. If you see, it was the use case was that a company is working on Android servers and making Android applications available for their clients, but if you don't install as a system administrator Android drivers, then the server is not going to work. It's not going to respond to any Android application. So that was one of the very important parts of the assignments that very few students missed. Although the volume of that was pretty high, because that was the core of the assignment, but I did not deduct up to too many marks out of that, so maybe 1 marks or 0.5 marks. I did that. So glad to see everybody has completed their assignment and completed that in a very good manner. I saw all the screenshots. I've seen that a lot of students have gone online, did some research over there and found out commands from there. It's absolutely fine, and you should be doing that, to be honest, in your real life. So it's absolutely fine to do that. And as I mentioned during the assignment and before, in the lecture before the assignment as well, that there are many ways of doing the same thing. So I can see that a lot of students have used different commands to make Debian packages, dpkg files. Some use make commands, some use other commands as well. So it's absolutely fine what you have done. I could see that a lot of students mention in their assignments that it took a lot of time, which is very normal. You are building a kernel, you're building an operating system altogether. It's compiling all the components, all the features of an operating system, so it's bound to take a lot of time. So for some students it took a couple of hours, which is very normal. For some students it took around 10 hours, which is a bit abnormal, but it's absolutely fine, because they had to do it a couple of times. So it's absolutely fine if that happens. Some students, majority of the students were very lucky that there were no errors during the compilation, but some of the students, unfortunately, because of running out of space of their disk or some other reason, they had to do it couple of times, which is very painful. I do understand that, and I consider that while marking your assignments. So it happens, but this is what is going to happen in real life. Not everything is going to be perfect. You are going to face a lot of problems which you are not even expecting. So it happens sometimes, and it's very frustrating. It's very painful at times as well. So this is what system administration is all about, because for system administrator there is not only one core area that you have to consider, that you have to work on. There are so many different things. So you are managing the whole system. You are administering the whole system, and whole system, you might sometimes have networking issues, you might have memory issues, you might have uh, many other issues, and you have to take care of all of them. That's why there is not only one system administrator in large organization. There is a team of system administrators that are managing these things. So as I said, it was I hope it was a good exercise. You understood what you had to do, and ultimately and finally you have completed your assignment, which is good to see. And I've already uploaded the marks for you guys. I hope you have already seen that. If some students you do believe that you deserve more marks, or maybe there is a mistake somewhere, please get back to me. We can always discuss that, and it's always a good idea to get back and discuss, even if it's not about the marks. I mean, mostly it's about the marks when it's assessment, but even if it's not about the marks, you know where you made a mistake and you don't know how to solve that mistake, we can still discuss. Or for example, you lost marks and you don't know where you lost those marks, you can always discuss with me. I'm free to discuss with you guys. I've already seen that few students have already asked that, which is absolutely fine. I like that. Discussions are always good. It's very unfortunate that we are going through this scenario where we cannot talk to each other face to face and discuss things face to face, but this is how it is right now, so we have to live with it. So that's pretty much it for the last week what we did. This week we're going to talk about system monitoring. You can see an assignment over here this week as well, but we are not going to do that right now. So you just completed one of your assignments, and I want to give you some just breathe, take some more time, and maybe we're going to do this assignment next week. So I'm not going to give you this assignment right now this week. No assignment this week. Maybe next week we'll see one more assignment, and we'll see what type of assignment it's going to be. Of course I'm going to explain that when we're going to conduct that. So this week no assignment, and we're just going to talk about system monitoring today. And I'm expecting that today's lecture is not going to be very lengthy as compared to our previous few lectures. I'm not expecting it to take too much time, because it's more of monitoring. I'm going to tell you about some of the tools, some of them we have already discussed about. I'm going to go in a little bit more detail about those tools and then we're going to use our foundation of bash scripting, which we learned last time, and going to run some scripts to see how we can automate few things. And this is the ultimate task, right, for the system administrator. Some of the things that you have to monitor, you might have to monitor them manually, but some of the things you can always automate them, or you might want to get some more information about something. So how you can do that, we're going to see that today. So, and how you can bring the bash scripting knowledge you learned last time into real world activities, we're going to see that. I'm going to do a couple of exercises for you, and I'm going to give you some of the exercises which you can try at your pace at home. So this is what we're going to do. So let's get started. So it's about system monitoring, and as I mentioned many times, that one of the core responsibilities of a system administrator is to just keep the system running. So my system administrator has to monitor system every now and then. He has to make sure that everything is running fine. There are no errors, no problems. If there are some errors, they need to be fixed somehow. And some of the major responsibilities is to check how many resources are being used, how much space. For example, if you have to check a disk space of a server, you need to make sure that there is enough disk space based on the pattern of how much disk space users are using in previous weeks or previous months. Then what type of users are logged in, how many type of users are logged in. Sometimes you want to check their activities to a certain level as well. For example, are they trying to access a private folder which they are not allowed to access? I mean, sometimes you need to track that, you need to log that. Obviously system is definitely going to log that, so you might need to check that as well. You might to check every now and then, were there some network issues last week or last weekend when system was automated and nobody was manually monitoring it. Was there any network issue? So you might need to write some log files if they are not already available, to check the system health, maybe network health or disk health or memory health during the weekends or during the week altogether. So you might have to monitor those as well. So some of these things you can do manually, which we have seen already, and we're gonna see some of them today as well. Some of them you can actually automate them, and we're gonna work on automation in coming weeks as well. But today we're gonna write some scripts to see how we can get some further information from some of our utilities which are by default available in Linux, or you might have to install third-party applications, but you can still get some information out of those using your scripts. So this is the core responsibility of system administrator, that system administrator has to make sure that everything is up and running, there are no problems, everything is going smooth. Then obviously system comes with resources. There are so many different resources. There can be web pages, there can be email clients, there can be printers, there can be scanners, many other things that system administrator has to make sure that these resources are always available. If something is going wrong, then it needs to be replaced or fixed. So system resources, obviously they are part of the system. When we talk about system, it's not only the server, it's the resources associated with that. uh, Now I'm gonna run a few commands with you over here, just to see how you can see or how you can monitor your system resources. The first of those commands is stop command. I have my virtual machine up, so let's go to terminal and let's run this command to see what this command is all about, what it shows us. So top command, it basically is a command that shows us the overall view of your CPU and memory. So if you see, it tells us how many tasks are running, how many tasks are total tasks are there, how many of them are running, how many of them are sleeping, how many of them are zombies, and so on. Then it tells you about the usage of CPU as well. It tells you about the memory as well. It tells you about the swap memory as well. If you remember last time we discussed about swap spaces as well. So this is the information for that as well, and this is the information for all the currently logged in users and all the processes that are running. If you see, this is the process ID of the processes, this is the user, and then the other IDs and so on, usage of CPU, memory usage, the time, and the commands. So a lot of information is being provided by top command. It has a lot of shortcuts. I'm not going to go through all of them. I leave that to you for exploration. So I'm going to use a few of them today. So this is for all the users, and these are all the processes being showed over here. I mean, at least the majorly used processes over here. We can toggle this information to see the idle processes. So we can see that there are some sleeping processes, also some idle processes also. Not necessarily all of them will be shown over here. So we can use I key, keyboard key, and if I press I, it will show us all the idle processes. So these are all the idle processes running over here, and I can always toggle back by pressing the I key again. It will start showing me this again. Then we can use M to sort based on our memory space. So it will give us the processes that are using the highest memory percentage going to the lowest one. I can always press M back again to go back and see how it's working. So this is how you can use stop. You can always press Control C to go back to console again, and you can get some help on top command using info top, and it's a very comprehensive utility. It gives you a lot of flexibility, so many things you can do with this. I've shown you only few of them, which maybe are the major ones, but there are so many other things you can do with this. This is all the information available. These are the flags which are available for you. You can use these flags as well. Yeah, that's pretty much it. You can go to thread level as well. If I'm not wrong, there is a thread level for this as well. So you can go to a thread level. There should be somewhere. It should be somewhere. So you can go to a thread level as well. You can go to different CPUs as well. So you can press -1. I mean, you can provide flag 1 to see that as well. So a lot of information, and this is what we did. We toggled the idle processes. Yeah, this is a thread mode, so you can use the thread mode as well. So something like this. It will show you the thread information as well. So all the information is available for you. You can use all this information to best of your use. So that's pretty much it for the top command. I don't think we have too many. Let me see if it has a B command as well. It doesn't have. Maybe that is for PS. Yeah, so that is for PS. So what we're gonna do is we're gonna move forward and see what else we have. So we have Iostate as well. There is another utility, Iostate. It also shows you similar information, but it tells you about mostly the running ones. So it tells you about the devices you have. So I have some devices, SATA devices over here, how much memory they are using. This is the CPU, how much CPU is running, how much is the idle state. It tells you about that as well. So it's a pretty neat command. I think we can go to help for this as well, if I'm not wrong. Iostate, and you can learn about a lot of flags. It has a lot of flags, and very useful utility when it comes to looking for memory information. I think we can specify, yeah, we can specify a lot of information over here. Maybe we can try one of them just to tell you how we can use it. So -C will provide a CPU utilization, which was here, along with memory as well. So if you want to see only the CPU utilization, you can do a -C over here as well. So, and obviously if it's not running for you, you need to install this package first of all. I think I already installed this, that's why it's running. So if this utility is not running for you, you can use sysstate package and it will start working for you. Then we have a PS command. It's quite a comprehensive command, very handy. So PS will display you the processes. If you want to see the list of all processes, you have to provide this flag PS-EF, and it will show you a lot of information over here, a lot of information. So your user IDs, then the commands that are being used, and then the time. It shows a lot of information. So if you want to learn about it, then obviously I think we can do a help as well. We can do help as well, if I'm not wrong. Okay, let's do info. So again, very comprehensive, very detailed information about this command. So we can use this. A lot of information is available when it comes to different processes, different threads. So you can use this information, and we can also show the hierarchy as well. I don't know if it's gonna work out of the box or not, but we can try. So I think it will start showing it in the hierarchical form, like this, maybe in hierarchical form like this as well. So it shows that information as well, and you can actually kill some processes from here if you want. So for example, I've just opened Firefox, and if I go back and see this, it will show me Firefox somewhere, but I think I can search Firefox as well, and that is through maybe flag. I need to maybe go to info to check what flag is it. Yeah, so we need to use maybe the grep command. So what we have to do is we can use pause AUX. If I specify AUX, you will see that it will provide me a lot of information. It will start providing me more information than it was providing me before using AUX. So let's provide all the information. So I can use a flag and a PS AUX, since I'm getting all the information, and since I want to get from this information some of the information I am looking for. So I want to search something, I can use a grep command. So dash I is a flag that is to find some text in it. So I want to search for, because you can see that there are a lot of processes over here, and if I start going and searching for Firefox myself one by one, looking here, it will take me forever. So I can use a combination of different commands. So what this pipeline does is, I think we have already discussed this, let me quickly explain this to you again. So what it does is it will combine those two utilities. So PS is one of the utilities, grep is another utility. So the output of this utility will be given to grep, and grep, what it does is it will search for Firefox. It will search for Firefox wherever it is occurring. So obviously Firefox will not occur here, not here and here. It will occur mostly in the commands, right? You can see that it's occurring normally in the commands. So it will search for us that. So if you are looking for some words or something, grep is a very good command when you have a utility that is providing you a lot of output and you want to search for very specific information in that. So we can use this in our, obviously whatever we are writing over here, we can use it in scripts as well. So we obviously can use this in script, and today we're gonna do an exercise, couple of exercises where I'm gonna use another utility, but you can replicate that to grep as well. So you can see that I have Firefox running. This is the ID, and in order to kill a process, I want to either I go here and close this, I can do that, or I can do a kill command. So kill PID means I want to kill a process by its ID, and the ID of this is 9649. If I do this, you can see that I have closed Firefox by doing this command. You can similarly do this for other utilities as well. Some of them, they might run on the startup, on boot up, which you believe that are not required. Either you can remove them from boot up, or you can manually kill them like this, or you can write a script to kill them. So you can do that as well. So PS command is pretty handy when it comes to getting information about the processes, and you can see that we have done one of them by searching one of the processes and killing that process. So this is a PS command. I'm not going to go into a lot of detail because I think we've discussed this PS command already, and I really want you guys to explore these commands. If I'm going to run everything over here, then you might not be able to search it yourself and do it yourself. So I've shown you how to do that. Info PS, just go over here, try to see what other flags it has, what other things you can do with it, and try to do it yourself. I've shown you one command which is grep. It's a very handy command, as I said in my previous lectures as well. So if you want to get some information from a specific output of one of the commands, you can combine two commands like this and get information from the output of one of the commands using grep like this. So try to do a couple of exercises yourself, how to get information from a lot of information using grep. Next thing is Vmstate. It's pretty similar to Iostate. It's just that the major difference between Vmstate and Iostate is that this will provide this information based on its last run. So if I run Vmstate now and then I run Vmstate maybe 10 p.m. at night, then this information will be between the first time I ran this and the next time I ran this command. So it will be between the two instances of this command. If I have never run this command before, then this command will show me information about the current time I ran the command and when I booted my computer, right? So maybe I booted my computer 2 hours ago. So this command is going to show me information of 2 hours, right? So it's going to show me that information only. It's not going to show me information for everything. It's going to show me information for that specific time span only. Next is ls off. I don't want to run this command because let me run it. So ls off is all the files that are running at the moment. Since Linux consider everything as a file, even all the processes that are running are also files, right? So that's why it was showing all of them, although you can see that I don't have too many applications running over here. But when I ran ps command, you could see that I have a lot of processes running, and when I run ls off, it ran all the files that are currently running. So all the processes, even they were files, right? So it ran all of them, and that's why the output is quite heavy over here. So if you are running too many things, then ls off might take a lot of time to run. And again, it has a lot of information about the users, about the commands, and so on. um, so you can extract some information from here if you want to get some information about the running processes as well. So yeah, it's handy in a way that it contains a lot of information, almost all the information about the processes. I think it has info as well, if I'm not wrong. um, doesn't seem to have it anyways. So but the main idea of using ls off is that it contains a lot of information about your running processes, and since everything in Linux is a file, so all the processes end up being a file. So that's why it's showing you all the information, right? So this is ls off. Then we have df command. I think we have discussed this before as well, so let me run this. So df is about your disk. It will tell you information about your disk. It will tell you how much it is used, how much is available, percentages of used and available. So it tells you about all the disks you have. So I have sdf5. So this is what I have right now. I have 84% of it used. I might need to get some more space. So this much space I already have, and I can get some specific information as well. So if you see right now, I have information like this. If I do like this, it will start showing me in human readable information, right? So if you see this one, it's just showing me in bytes. Now it will start showing me in gigabytes and gigabytes and megabytes. So it will start showing me information in that format. So dash h is for human readability. So if you want to get some more information in the form of these scales, you can do dash h. And obviously, since we did our one lecture on this and we used this quite comprehensively over there, I'm not going to go into a lot of detail of this, but obviously you can do something like this. So if you want to get information about a specific drive, you can do, and it will provide you information about that, right? And if you don't want to get all this information, you want to get specific columns, obviously you can do that. So I think we did this last time. So you can provide a parameter of output over here. So I want to get avail maybe, or let me do size first of all. So I misspelled. Output is equal to maybe size and avail, and it will provide me information about those specific columns as well. So you can do that. I think we did this last time as well, so I'm not diving into that because we have an exercise coming up which requires this one. So that's df for us. We've talked about this. Du is another command that is used to provide you information about your files, about your disk spaces. So for example, I want to get the size of a particular folder. Maybe I can do that by doing this. So maybe I want to get the size of one particular folder, maybe documents, and I need to provide dash s for summary. That will summarize the size like this, and maybe I can provide dash h as well if I'm not wrong. So if I provide dash h, it didn't change anything. Anyways, you can get the size of a particular folder by doing dash s flag, and du is the command that helps you in doing that. Otherwise, if you write du like that, it will provide you a lot of information about all the files, specific files on your directory, and it will be very heavy file, right? It will contain so much information. So this is du command. And what else? Yeah, who command. I think we already talked about who command. So who command will tell you who is signed in, like this. If you provide w only, it will provide you more information, like logging time as well, then idle, then so many other things. It will provide you some other things, and provide you for that specific user as well. So we can do that. And ps command we have already seen. What I want to do is I want to write some scripts. Basically, I have a file for you, for an exercise file for you that I have prepared for you, and I'm gonna solve that for you, few of them at least. I want to solve a few of them for you at least, and rest of them you can try it at home. Maybe you can do different variations of that. So I'm gonna upload this file as well for you, and let's see how we can solve this. um, so first one is make a process sleep in background for 30 seconds. So there is a command called let me clear this up, which is called sleep command. We can use this command to make a process sleep, right? Now for how much time we want to make it sleep, that's another thing, and we can always get, I think it's info help about sleep commands as well. So basically it's we need to provide a parameter that is some seconds, uh, uh, if I'm not wrong, and then that will work, right? So if I want to do, if I want to make it for maybe 5 seconds, it will go to sleep like this, right? And I can always force close that by Control C or Control Z. I can simply make it sleep for 15 seconds like this. So I can do that. This current process, my current process in shell has gone to sleep now, right? So, and it's on the foreground. The problem is it's on the foreground, right? Now sometimes what I can do is, and this is I think what the exercise is saying, that I have to make it sleep in the background, right? I have to make that sleep in the background. So we know that we can make a program run in the background and foreground, or background or foreground, by doing something. Let me do 5 seconds, and I can do an ampersand sign like this. And it's sleeping, but it's sleeping in the background, right? It's sleeping in the background. I can see PS. You can see that this is the one which was sleeping over here. So this is how you can make one process sleep, and then when it's done sleeping, it will also provide you information that I am done sleeping, right? So you can do something like that. Let me do it again. So let me make it sleep for 20 seconds in the background. Let's do that. And if I do PS, you can see that two of them are here. So I can kill one of them if I want, or maybe two of them. Kill PID, what is the ID? 9988. And if I do PS again, you can see one of them is gone. Well, I think you can also do a kill without providing PID. So you can try that as well. So I'm gonna clear this up, and maybe let's move further. So the next one is write command to display all the processes running for a specific user. So we know that we can run processes doing something like this, PS, and it will show us all the processes. So if we want to see all the processes, we can do something like this, but it's showing me all the processes from almost all of the users, right? It's showing me for all of the users. So I want to get it for a specific user. I can do that. So in order to do that, I can do PS and I can specify the U flag over here, and then I can specify the name of the user, and it will display me all the processes from a specific user. And similarly, I can see it for the other users as well. So I can do PS dash U, can do a root, and it will show me information from those as well. And yeah, that's pretty much it for PS command as well. So we can do that. And these are pretty easy commands. This is what I said, it's not going to take too much time. But when we are going to write some bash scripts, maybe here, they might take some time. So let's quickly go through all of them. So write a command to get the PID of a process. So there is a utility that is PID off. So let me run Firefox. We could have run bash as well. So I can do something like this. So PID off bash, and it's going to show me the ID, process ID for that. So if I do PID of Firefox, it's going to show me the ID of Firefox. Firefox is running multiple processes, which is absolutely fine. It can run multiple processes. So This is what it looks like, and it's very easy to get the IDs of specific processes if you want, and that too from our specific window. I mean, I'm doing it for bash, so it's gonna give me this specific window, the ID of this specific bash terminal. So we can do that. All right, what else we have? Write a command to show all the current idle. I think we did this, but obviously we can do that for a specific user as well. So in order to do that for the specific user, we have a command like this, top, and for top we have -u as well, so I can specify that, and it will display me the processes for all processes for a specific user, and over here I can toggle by pressing I, and it will show me the idle processes for that specific user, right? So that was pretty simple. Then write a command for displaying only the source size and available space for, I think we did this, but I'll quickly do that for you again. So let me clear this up again. So I'm gonna do df, and for one specific disk, my disk is SDA5, and dash output is equal to size, I think source, or maybe it was available. So we misspelled something, it's not available, it's avail. So we got something like this, right? So we can get specific information like this. It's pretty simple, pretty easy. And obviously if I want to do it in human readable information, then I can do a dash flag over here, -h flag over here, and it will start showing me in gigabytes over here. So that's how you do it. Pretty simple, not difficult at all. Now let's see what else we have. Okay, so yeah, so now we have to run a bash script. We have to write a bash script over here to see if a process is running or not. Okay, so yeah, so as you know that I have just run the commands for the processes for you. So for example, we ran PID off. So if I do Firefox, if I do something like this, it will return me the IDs of the different processes Firefox is running, right? And it also actually returns, it shows me this one, but it actually returns 0 or 1 if my process is running. So if as you remember, when we were writing our programs in C language, we used to return 0 from our main method, right? 0 means that execution of that method has successfully completed and there were no errors, right? But if it's not returning a non-zero value, if it's returning a non-zero value, then there might be some error. Those values are normally used to specify some errors. For example, if a process or a function is reading through a file, and that file is not available, I might return a code 404 saying that file not found. If there is permission restrictions on that file, I might return something else. If the file is available but it's not available to be read by that specific user, I can do that. But if everything went fine, then the return flag will be a 0 flag, right? So same thing is happening over here. If this command ran properly, which means that this process was running, then it will return a 0 as well. With this one, it will return a 0 as well, and that we can save in a variable, and we can check that variable. If that variable is 0, then it means that process is running. If not, then it's not running, right? So we're going to write something very simple. So okay, so let's write that script. I'm gonna save it somewhere. Let me save it in my temp, and I'm gonna call it maybe exercise 8.sh. So it's a script, so the extension is going to be sh, and I'm going to save it. And in order to tell your interpreter that this is a bash script, we have to start it, if you remember, like this, right? And I'm going to give it the path of my bash, which is this one. And then we have to first of all get if the flag returned by PID command is 0 or 1. So I can write PD of, and I'm gonna say the specific program or the process Let's try to run this. Let's see what happens. Let me clear this up, and let me just move to my temp folder. I have to, before running this, I have to give it my execution permission, so which is this, and the name was ex8.sh. It's done, and in order to run this script, I'll do it like this. So what it's gonna do is, right now it's returning me PID of Firefox. This is exactly what I'm looking for, right? This is exactly what I'm looking for. You know, if I do echo here, and if I do a flag like this, this is going to return me the flag returned by this command. So every time I do an echo $? It's going to return me the value returned by this function, right? So either it returned a 0 or 1, but PID of basically is itself is a cout command, or an echo command that is displaying me the process IDs of this. But at the same time, it returns to me some flag also, 0 or 1, an error code, right? If it's an error code, then it's greater than 0. If it's not greater than 0, it's a 0. Then it's not an error, right? So let's see if I do something like this, what happens. If I do this, you can see that it returns to me, it's displaying these process IDs, but it's also returning me a 0, right? It returns me a 0, which is the value returned by PID of Firefox, right? Which means that this process is running. Now I just simply have to check this. If this one is 0 or 1, I just have to run an if and else command. If it's 1, then if it's 0, then the process is running. This is exactly what we want, right? We have to write a script to see if a process is running or not, right? So we can do that. So I have to just check. So instead of displaying this return value, I'll just save that in a variable. So I'm going to save that in a variable called result. I'll do that, avoid spaces, it can create problem. And once I have this, I'll just check in an if statement like this, that if result is equal to, if you remember we did something like this, if it's equal to 0, then echo something, echo process is running, else echo process not running, and then phi to close it, right? This is how we do it. And what I'm going to do is I'm going to run it again. So it should be is okay. So what it did is it actually showed us the information. So since it was returning 0, it's saying the process is running. Let me close this Firefox and let's run this again. Process is not running, right? This is exactly what we were looking for. So this small script can now tell us if a process is running or not. And you can take this input from a user as well. You can take this command line argument as well to see which process you want to check if that process is running or not. So this can be a very, very handy script for a system administrator. If system administrator wants to see, well, you can use a grep command from top as well, like I told you, because PID of or any other utility that is going to return you, for example, if you are going to run a ps command like this, or ps-ef, if you want to run this one, then you have to find from here which process is running, like what I said last time. Either you do this, run it like this, you use a grep command to search for something, you can do that as well, or you can use a very simple handy script over here like this that can actually tell you if certain process is running or not. So this is, I think, one of the exercises we just completed. And it was, I think, not very difficult. It was pretty straightforward. We just ran a command, and this command returns us a 0 or 1. If it's a 0, then it means the process is running. If it's a 1, it means the process is not running. And we save that value. If you're going to use this, it means that it's going to return us the return value of this one. If you remember functions, what we did for our bash scripting, they do something exactly similar to this, right? They do something like this. So if I do echo for that function, it's going to return us the value for that function, right? So we are doing something very similar over here. We are just returning this into a variable, storing that into a result variable, and then in an if statement we are just comparing that value with 0. If it's a 0, then process is running. If it's not a 0, then process is not running, right? Very, very simple. Okay, let's move further. So write a bash script to check the available space on your disk, and if it's less than 50 MB, display message. Okay, so we have to check the space on the disk, and if it's less than 50, we have to display a message. If it's not, then it's fine, right? Now, these type of scripts, they can be very handy in doing a lot of things what system administrator wants to do. Some of the utilities or some of the programs, they do not provide you specific information, right? For example, this can be done through df command. So let's do a df quickly just to show you that what I'm talking about. So if I do a df, and if I want to do a df on a specific drive, I know I can do that. So it will display me this information, but it's not going to tell me that I'm running out of space, right? Well, obviously operating system is going to tell you somehow, but sometimes your drives are not primary devices drives, and operating system doesn't care if that is running out of space, right? So what you want is, you want some indication or an alert or something, or an email maybe, to tell you that okay, this thing is running out of space, you need to do something about it, right? So in that case, you can write a script. What that script can do is, it can alert you about the space of your hard drive, or maybe RAM, or maybe CPU, or maybe if something is not working. And the scripts can email you as well this information. It can send you an email as well, right? So I'm going to leave that to you. I'm not going to go complicated into this. I'm going to make it very simple. I'm just going to create a script that is going to show us a message if the space is less than 50 MB for that particular drive, then I'm going to say low space. If it's not, then I'm going to say maybe enough space, right? So first thing is to get this space. So the available space is, we want to get this thing, this column, this specific column, right? We want to get this specific column. Now you can try doing it with grep. I told you how to do it, and I think we discussed it in previous lectures as well. I'm going to use a new command which is called an awk. I want to give you a feel of a new command as well, because it's a very good utility and you can use it to do a lot of things, and it's a very handy utility. You can always use grep if you want, no problem. So you can do that way. I'm going to use awk. So first of all, we know that we have received this information. Out of all this information, we want to get this column, and not even this column, this value, this specific value. We don't want this one, we just want this specific value, and we just save this in a variable. We compare it with 50 MB. If it's less than 50 MB, we display alert message. If it's not, we will display some other message. Really, this is what we want to do. All right. So we have this. From here, we need to extract this value. So as I said, we can use awk command. Awk command looks like this. This is the command, and it has a lot of parameters. It's a very handy utility, and it can provide you a lot of information, right? So for example, let me quickly go through awk first before we actually find a solution to this problem. AWK actually works like this. So for example, I want to display something on the console. I will do something like this. I will say hello world, and if I want to combine the output of, or utilize the output of this command, for example, awk wants to output the utilize the output of this command, we can do something like this. So awk, then single quotes, inside this I'm going to put a parentheses, and I'm going to print. So if I do something like this, it's going to display me hello world, which is, if I don't write this part, even then I'm going to say hello world. So nothing special over here. But if I do something like this, $1, it's going to take the first parameter only. It's going to take the first parameter only, and it displays us only this part. Similarly, if I do like this, it's going to display me the second part, right? Very simple. So, and if I want to see all the parameters, I can do either print 0 like this, or I just don't put any parameter. I do something like this. So this is how AWK works like, and it has a lot of other options as well, which I'm gonna show you in a while. But just wanted to tell you quickly that what AWK does for us. Just like grep, it's another utility which helps us in processing our text and extracting our text from the outputs of other commands, right? So our aim again is to find out the space and then display the message based on the value, right? So let's do that. So first of all, let me remove this. First of all, what we have to do is we have to do something like this. So let's write the command over here. Df we want to get, or let me write this command, or let's do it over here, no worries. So we have to write a command. So we want to get information from this command, right? SDA5 in my case. Your drive might be different, and whatever output I'm getting from this command, I want to provide that output to AWK so that I can extract my required information, right? Because as you see, without using AWK, I'll get this information, right? I don't want to get all this information because I'm not looking for everything. I want to get only this variable, this value, and I want to place this in a variable. If I don't do that, I won't be able to compare it with 50 MB, which is a requirement of my exercise, right? So I'm gonna give this output to AWK, and like we did before, we are going to use a single quote. So I'll do a single quote, I'll do curly braces, I'll do print, and let's run it like this. Let's see what happens. Okay, let me do that. It's ex. Oops. Yeah. So if I do that, it's displaying me again the same thing. So it didn't work, right? It didn't work, but it won't work. Just like what happened to Hello World, because I'm displaying everything over here. What if I do $1 here? Let's see what happens now. If I do $1 here, you can see I'm getting this part, right? So first column and its value, I'm getting that. So, but I'm not looking for that. I'm looking for this column, which is 1, 2, 3, 4, fourth column. So let's put 4 over here, and now run. You can see that I got this value available and this one. Now, if I save this in a variable, it's not going to work because it's going to save for me available as well. It's going to save for me this number as well. I want to get only this number. I don't want available to be there, right? Because I know this value is available. So I don't want to get available over here. So in that case, what I can do is, that's where the power of AWK comes in. You can use these values in the form of lines. So this is my line number 1, this is my line number 2, and if there was another line there, that will be line number 3. So I want to get the information on line number 2, right? This is my line number 2, this is line number 1, this is line number 2. So I can specify that. In order to specify that, I can do something like this. NR is equal to 2, because it's line number 2, right? I want to get value on line number 2. If I run now, you can see that I got this number now. Very, very easy, right? I got this particular number now. So this whole command gave me that particular value instead of getting everything like this, right? So everything like this. And this is how you can extract information from the output of some utilities, and then you use them as per your need, right? And what I have to do is, since I got this number now, I just have to save this in a variable. I have to save this in a variable. If you remember from last exercise, when we want to save something in a variable and we want to run the commands, we do something like this. Remember last time we did this. I think I did it for ls, if I'm not wrong. If I do something like this and I run this, it will not display anything. Well, definitely, because I did not echo anything, right? If I do echo and do a var, my variable, let's see what I end up getting. I get this value, right? It changed a bit, obviously, because the size of my memory is changing. That is absolutely fine. This is my disk space, it changed it, which is absolutely fine. So I got this value now. I just have to compare this with 50 MB, and that's pretty much it. I'll do that in an if statement, and I'm almost done. Let me remove this. I don't need that anymore. I'll just compare it with my 50 MB. So that's how you do it. So I'm gonna do $var if it's less than 50 MB. Less than 50 MB. What is 50 MB? Let me do it accurately. So 50 into 1024, I mean something like that, right? I'm not going into detail, but I mean you can see that. So something like this, and obviously I have to remove this comma, and then semicolon over here, and then here I'm gonna echo this. If it's less than, then I will say whatever message, running out of memory, running out of memory, running out of disk, let's say disk, memory is RAM, and else I'm gonna say maybe enough memory, enough disk space, and I'm gonna finish it by doing a fee. Let's run this now, and it's gonna say enough disk. Wow, it's a disk. Okay, so it says enough disk space, obviously, because I do have enough disk space. It's more than what I need, so I have it over here. This is how you normally do it. And if you wanted to get any other part of this specific command, you can easily do that, right? So you can check this one. For example, you want to give a quota to specific students or specific users on your system. You can maybe use this one, and when users have reached maybe 10 MB or 100 MB or 1 GB, you can show them an alert, right? This can be another useful script that you can write. So that's how you do it. It's pretty easy, not that tough, nothing so difficult in that. I hope you understand what we are doing. I hope you got it. And let me quickly do the next one for you as well, right? I'm gonna do the next one for you, and then we'll see what you can do as well. So I'm doing everything for you. Anyways, this is just a practice for you guys. At least you can see how it is done, and then you can try it on yourself. Okay, so what this says is write a bash script to check the free RAM. So okay, in this case we are going to check the RAM, right? Not the disk space. We are not going to check the hard drive space. We are going to check the space for our RAM. And I hope you remember how do we do that. We use cat /proc/meminfo. Yeah, and we have to find which will be on the top, free space, right? Mem free space. So we have to use this part of our function. So we need, out of the output, we need to extract this value. Very simple, just like what we did before. We are going to do it over here. So I'm going to remove this. I'm going to make use of the same program. So I'll do cat /proc/meminfo, and I want to use awk again, and let me print everything first. Print, just to make sure, and let me remove all of this, and let me echo this. Let's see if it works. Okay, yeah, it's showing everything. It's showing everything, and it obviously is not showing it very clearly, but you can always do that. It's all about decoration. So you can decorate it as per your need, but it is displaying me everything. I need to get this information, right? Mem free, right? Yeah, that's what I'm looking for. So let me see this thing, or I can do it that way as well. Both ways are fine. So what I want to do is, this is my second line, and it's going to be my if I'm not wrong, second parameter. So this is the first one, and this is the second one. Let's try. Let's see the first one. Let's see the first one. It's showing me everything. Let me just trim it down to line numbers. So let me do nr is equal to 2, so that it shows me only the second line. Yeah, so it's showing me mem free, which is exactly what I was looking for. And I need this one, this part of the value, not this one. I'm looking for the value, not the header. So what I'm doing over here is $1. So I'm going to do a $2 over here. So let me do $2, and it's returning us the value, which is what we were looking for, right? So it's absolutely fine if it changes, because RAM value changes very quickly. You cannot expect it to be same value every time, right? So rest of the things I think should be similar. What we did before is just that we need to change a value. So let me do it quickly for you. I shouldn't have removed that program. Anyways, so let's do that. So end of var is less than, maybe, I don't know, I'll just try some value, maybe like this. If it's like this, then echo low memory, else echo enough memory, and fee, like this. Let's run this now. It has low memory. Why is that? Maybe I have put some extra zeros over here. Anyways, so this is how you normally make these things work. It should work absolutely fine now, and that's how you do it. I think we have done most of the exercises over here. What you guys can do it, you can do all of these up till number 5 in a script. Try to write a script for this. We did it in terminal. You do it using a script and then run that in terminal, right? And also for these three, I have used a new utility, AWK. What you can do is you can try it with grep. Try to do it with grep. It will be an exercise. It will be a good exercise for you guys. Try to do that. Try to do some other things as well. Maybe try to get the name of the user. Try to get the processes. Try to get a specific process. Kill a specific process from the script and stuff like that. Sleep, make it as make a process sleep from the script. So I think you can do a lot of things in scripts, because most of the things we have done in terminal, you can do all of those things in the script, but make sure you do some computations on that, right? So if you are running something, I could have run simple commands over there and do nothing, but what we are doing extra over here is we are getting all this information which we ran on the terminal and saving it in a variable, and then making some computations on that variable, right? So do something like that. Don't just run these commands in the file. It's same as running the command in terminal. It's just that you are saving it in a file and running that file. It's not going to make a lot of difference. But these things normally you don't do in terminal. Normally do it in script. Multi-line of commands you normally run in scripts, right? So do something like this. It will give you a lot of understanding of how scripts work and how powerful scripts are, and you can do so many different things with this. It's all about getting ideas of what you actually want to do. It's all about your requirements as well. So these are the things we are displaying this information on the terminal. Your requirement might be to send an email. Whenever that happens, try to do that as well. It's not very difficult. You have to just use a mail parameter over here, which is not too difficult. You can search on the internet how to do a mail from your script. So you can try that. For example, another thing you can try is signal, Wi-Fi signal, right? Try to see what is the strength of your Wi-Fi signal. You can try that as well. And if signal is low, display some message. If signal is below some threshold, you can display that message as well, or do some other things as well. There are so many different things you can do with scripts when it comes to automating the job, displaying messages or alerting. That's pretty much it. As I said, this lecture is not going to be very lengthy. We have covered few things today, and I have explained to you how you can use these utilities in your scripts, bash scripts. They are pretty handy, as I said, and you have seen that we have done some real life examples as well today, and you can do some other examples as well. In the next class, we are going to move further, and we're going to continue using scripts so that you actually get to know how powerful it is and how we can use it. And we're going to talk about assignment maybe next week as well. So if you have any questions regarding this lecture, any previous lectures, maybe regarding assignments or anything, please join me in my virtual office hours. If not, you can always drop me an email if you don't understand anything. and I will get back to you as soon as possible. That's it from my side. If you have any questions, please do not hesitate to talk. Thank you. Bye bye. Have a nice day.